Today we'll look at systems of inequalities. Before we looked at equalities, now inequalities, and graphic method is the only method. Let's recall from Algebra 1. We're going to solve and graph on a number line. Okay, so negative 3x, I'm distributing the negative 3, plus 12 is greater or equal to 24. Subtracting 12 from both sides gives us a negative 3x greater or equal to 12. Divide by a negative 3. Recall from Algebra 1, if you multiply or divide by a negative number, turn the inequality. Okay, you turn the sign. So I've divided by a negative, so I'm going to turn the inequality. Now we're ready to graph. I'm just going to put our significant number there. And the question now is, do we want to open or close? Since it's equal, we want a closed dot. So I'm going to make sure that's filled in, and less than, we go to the left. And now make sure you understand what our solution is saying. It's saying that all numbers less than or equal to negative 4 will make this equation true. So let's say I pick negative 6. It's over here. If I plug it in, and this is just a test, which you don't have to do, we'll get a true statement. So I get negative 3 times negative 10 is a positive 30, and that indeed is greater or equal to 24. So that was just a little test to see if I shaded the correct way. Example 2. Let's graph, but now on a coordinate plane. So I'm going to go to 2, and we know that x equations are vertical. So I'm going to ask myself, do I want solid or dotted? It's not equal, therefore, I want a dotted line. So I'm going to go dotted, and now I'm going to shade all points. It says less than, so less than goes this way, and I'm going to shade all points. So notice that there are infinitely many points that make this true. I could test any number of points. That point is 1, 1. It has an x value that is indeed less than 2. Notice anything on the line will not make this statement true. Let's do a line here. I'm going to go to negative 5. Slope is 3, up 3, run 1. And now I'm going to ask myself, solid or dotted? Well, it's equivalent, so that is a solid line. So anytime you have the equal bar underneath, you can make it solid. And now the question, whenever there's an x and a y, the question is, do we shade above or below? So if you have y is less than, that means less than means shade below. And if you ever have y is greater than, that means shade above. So in this situation, y is greater than the line. So that means I'm going to shade above the line. And I always like to look at the y-axis. See, this is where y gets big. This is where y gets small. So when I'm shading above, I want to shade where y gets large. I always have students say, Miss Adams, do I shade to the left or the right? No, it's above or below whenever there's an x and a y involved. Now, I need to get, let me get rid of this stuff. I need to get y by itself. So I'm going to subtract 2x from both sides. And now I have negative y is greater than negative 2x plus 6 multiplied by negative 1. So now I have a positive y, but turn the inequality when you multiply or divide by a negative number. So now I can go to negative 6. 1, 2, 3, 4, 5, 6. Slope is 2, up 2 over 1. And now is it going to be solid or dotted? It's not equal. Therefore, I want a dotted line. Dotted, not solid. And now am I shading above or below? I want to look here. And it says y is less than the line. That means shade below the line. And that's not very neat, Miss Adams. So now, let's make sure we understand this solution. Any point in this shaded region, no matter what point you select, will make this inequality true. So let's say I take 1, 2, 3, 4, 5, negative 2. And I could pick any point in this shaded region. And if I plug this in for x and this in for y, if I've done everything correctly, I'll get a true statement. 10 plus 2 is 12, and 12 is indeed greater. So I have a true statement, and I feel pretty confident that I've shaded the correct direction. Example 3. Let's graph this parabola. Well, the first thing we have to do is find the vertex. So I'm looking at x equals negative b over 2a. That's our axis of symmetry. And so we get 2 over 2 is 1. And now I can plug 1 in and see what the y coordinate is. Uh-oh, that should be a 1. So we have 1 minus 2 plus 5. That's negative 1, and 5 is 4. So our vertex is 1, 4. Over 1, up 4. And now this vertex has a equal to 1. So it's positive, and 1 squared is 1, 2 squared is 4, so forth and so on. And is it solid or dotted? It's not equal, so this is dotted. And now, do I shade above or below? Well, it says that y is less than, so less than means shade below. So I like to start at the vertex and go below the vertex. But notice, not only do I get these points, but I also get these points out here. I always have students say, Miss Adams, do we shade inside or outside? Has nothing to do with that. It's above or below. Keep that in mind always. As well, you could absolutely test a point. I always like testing the origin because that's easy. So if I test, I get 0 is less than 0 squared minus 2 times 0 plus 5. And let's see if we get a true statement. Well, 0 is absolutely less than 5, so true statement, and it looks good. Moving on to example 4. Let's solve this system. So hopefully you remember this from Algebra 1, but I do want to do a quick review with you to make sure. So here, I'm going to put this in slope-intercept form. So I'm going to subtract x from both sides. I get negative y is less than negative x plus 5. I'm going to multiply by negative 1. Don't forget to turn that inequality when you multiply by a negative number. Let me make sure I changed all my signs. Negative became positive. Negative became positive. Positive is negative. So I'm going to go to negative 5 with a slope of 1, up 1 over 1. I'm going to ask myself, is this line solid or dotted? It says y is greater, so that's dotted. And am I shading above or below? Well, y is greater means shade above. And so I get all of this. But that's only for the first line. So now I want to change up and do the second line. I'm going to put this one, in slope-intercept form. So I get y is greater or equal to a negative 2x plus 3. So I'm going to 3, and I'm going to go down to run 1. And solid, because it's equal, I'm going to make my solid line. And now I need to figure out, am I shading above or below? Well, it says y is greater, so I'm going to shade above. And now I'm looking to see, where did these overlap? And I can see it's this region right here where I have my overlap. So now, and you can see why, hopefully you can see why we have to use the graphic method, because there are infinitely many points in this region, and every one of those points makes this system true. So I could pick any one of these points. What about 1, 2, 3, 0? That looks like a good point. And if I plug 3 in here and 0 here, 3 here and 0 here, both of them will give me a true statement. For the first one, I'd end up with 3 is less than 5, and that's true. And for the second one, I'd end up with 6 plus 0 is greater or equal to 3, and that's also true. So I know I've shaded the correct region. Now, I just want to give you a little extra practice on shading. So this first one says, y is greater than this parabola. Greater means shade above. Above. So I go to the vertex and I start shading above the vertex. Now let's look at this line. It says y is less than the line. So if y is less than the line, that means go to the line but shade below the line. It's not a question of right or left. It's a question of above or below. So when we look at the y-axis, this is above and this is below. So notice I've shaded the part where y gets smaller. Okay, here we have a parabola. I'm going to go where y is greater. So I go to the vertex, and greater means up, so I'm shading above. But notice I have to shade everything on this side of the parabola. And lastly, I've graphed an absolute value function for you. This one says that y is less than, so I can look at the vertex and go below. Okay, hopefully that does help a little bit as far as which way to shade. Now let's look at our final example. We're going to solve this system. Looking at the first graph, it is a line with a slope of 1. And so I'm going to, first of all, I don't like the way that line is. Let me redo that line really fast. It wasn't on the graph paper just right. Okay, so now I'm going to start at 0 on the y-axis, up 1 over 1. It's not equal. So this is indeed a dotted line. And so I'm just going to make that dotted. And do I shade above or below? Y is less than, so I'm going to shade below. Wow, it's not that neat. Okay, but hopefully you understand what's going on. So I'm shading below. Okay, now before I can do anything here, I have to figure out the vertex. So x equals negative b all over 2a. So I'm looking at negative a negative 8 and 2 times 1. So that gives me 8 over 2. So my x value is 4. Now I'm going to plug that in. 4 squared minus 8 times 4 plus 14. 16 minus 32 plus 14. That gives me a negative 16, and 14 is negative 2. So my vertex is 4, negative 2 over 4 down 2. And a is 1. So 1 squared is 1. 2 squared is 4. 3 over 3 up 9. And we have our parabola. Oh, I did that point wrong. And is it solid or dotted? Well, it's equal, so it is solid. And now am I shading above or below? Y is less than, so that means shade below. Let's change colors. So below this parabola would be everything below the vertex and on that same side of the vertex. So everything on this side is below. Now, I need to see where this overlaps. And it appears to me, yellow and blue make green. It appears to me that the overlap is right here. So this is the solution. When you do it on your homework, please be very neat. Students like to use highlighters, but remember you can't erase if you use a highlighter. And so you want to be really neat, and it's nice to shade with the side of the pencil. Just make sure the solution is very